Dear students, let's see the another example on the logical and physical address. On a simple paging systems with 2 to the power of 24 bytes of physical memory, 256 pages of logical address space and a page size of 2 to the power of 10 bytes, how many bits are in a logical address? This is the question that is being asked. Now, in this particular case, I just always says, keep this one in your mind, that logical address space and number of pages and page size. You always keep it in number of pages you put as P and this one as D, or whichever you like it. So here I have given a notations D for size and P. So I have drawn here this one. You can put this one on the left side and this one on right side, or whichever way. There is no dissimilarity. So now here in the logical address, in the given questions, the logical address is having 256 pages. So 256 pages, what it means is that it is an address. It talks about the pages is nothing but address. So 2 to the root 256 means 2 to the power of 8, that is in the pages. And these pages will occupy how many bytes page size? 2 to the power of 10. So what is 2 to the power of 10? 2 to the power of 10 is nothing but this 10 is nothing but the page size, that is D. And what is 2 to the power of 56 pages is the address, so that is 8. So what is the logical address space? So logical address space is equal to 8 plus 10, that is 18 bits. So it needs 18 bit. So that is what. Now let's see the university question papers. One exam problem. Consider a machine with 64 MB memory and 32-bit virtual address space. If a page size is 4 KB, what is the approximate size of page table? Now, in this particular case, if you try to see, again, just take this figure only for your easy understanding. Now, here it is given 64 MB memory. 64 MB memory, what does physical memory? That is a main memory. And 32-bit virtual address. What is that? This is a virtual address space is for a secondary memory or a logical address space. Page size is given 4 KB. 4 KB is page size, so that is this one. So what is 4 KB? 4 into 2 to the power of 10, that is 2 to the power of 2 into 2 to the power of 10, that is 2 plus 10 is equal to 12, that is 2 to the power of 12. So that is the page size. So this is 12 it becomes. Now what is being given in this case is 32 bits. That is the logical address space. So 32 is given here and this is given 12. So what is this one? What is the page number of pages? It is 32 minus 10. So 32 minus 10 is nothing but 20 pages. So that is what is given here. That is 20 pages. So P and Q is 20 and 12. Now coming to the second part. The second part is given 64 MB physical address memory. 64 MB physical memory, what does it means? It talks about the physical address space. So 64 MB means M is 2 to the power of 20. That is 1 MB is 2 to the power of 20. 64 MB is 2 to the power of 6 into 2 to the power of 20. That is 2 to the power of 26. So bit size is 26. So what is physical address space? Physical address space is frame numbers plus frame size. So what is frame size? Frame size is same as the page size. So this same as T. So that 12 is coming, this 12 is coming here. And what is given? 26 is nothing but your logical address logical address space, that is VAS. So logical address space minus 12, that is 14 is in that. So this is 14 and this is 12. So this is actually this physical address space is how much you need a 20, so that is 2 to the power of 5, you can take it. So this is 4, this is 4, so logical as 2 to the power of 4, so this means it will become 16, so nearly 14 bits. So what is the advantage? It is simple and fast, no need for lookup tables, and flexible. Lookup table is means there is a table structure is coming between the physical logic page and a frame. Memory what is the disadvantage? Memory allocations may result in external fragmentation and do not allow easy sharing of the space. External fragmentation means now this is, now let us say this is a pages, frames. This is a pages. Now this address, if it is it has to allocate here. Sometimes this spacing may not able to occupy, so it has to split into different spaces. So that's why it is termed as external fragmentation issues. Now let's see the one more examples. Now in this example, in a 64-bit machines with a 2 GB RAM and 8 GB page size, how many entries are there in a page table if it is inverted? You forget about the timing the word inverted. You focus about inverter means it is taking into consideration the physical as well as the logical address table structures. Now 64 bit. Now if you take a 64-bit machines, that is, it is talking about a logical address space. Now 2 GB RAM. RAM is coming to where it it talks with a 2 GB RAM and 8 GB page size. So that is the, actually it is not a PAL, it is a physical address. It's a main memory. It is not a L, it is a P. For your information, this is a physical address space. So this is a logical address space and logical address page size. So 64 means 2 to the power of 64 bit is already given. Now coming to the 8 GB means 8 into, that is 2 to the power of 2 to the power of 20. So that is 2 to the power of 2 to the power of no, this is not GB, this is KB, sorry, KB, you take it into understand. For a mistake I have written as a K, so it is a K. Let us take it as a K. You convert this one into change to K. So 2 to the power of 10, so 2 to the power of 13. You can do with GB also, no problem. So I taken a 2 to 13 bytes of a page size. Now this is 64. 64 minus 13. 64 bit is, what is this one? This is a logical address space. Logical address space minus the page size will give you the page numbers. So 64 minus 13 is 51. That is same thing as 2 to the power 64 divided by 2 to the power 15 size. Now coming to the question is that it is asking that if a 64 machine with a 2 GB RAM, if a 2 GB if you are taking into considerations, the size of the page table will be very big if a 4 bytes entry size will be. So 2 to the power 51 is our page size, and if you take a 2 to the power of 2, that is a 2 to the power of 53. So 2 to the power of 53 is a this is easy to handle. Hence we use the inverter page table to store the entry for a physical address 2 GB RAM. 2 GB RAM means 2 into 2 to the power 2 to the power 31. 2 to the power of 31 is nothing but your 31 is indicating your RAM size. So what is the this is actually 31 is a RAM size, but it is a physical address space 31. Now what is the page size? That is same as this one. So 31 minus 13. 31 minus 13 is nothing but 18. So this is the page size. That means if we use the RAM of 2 to the power of 31. So that is a physical frame. Which other? What is the page size it is being asked? So it, in this case it is coming as 2 to the power of 18. Now if you see this one, if you are taking the case of a 2 to the power of 51, 2 to the power of 2 is nothing but a 2 bit. Let us take 51 size of the page table, and 2 to the power of 18 page size of page, which is convenient. 2 to the power of 18 page size. So we use the inverter page table store in the physical by using a RAM. So if you are using a RAM additional memory, so automatically page size structures will be able to reduce. So this is the final answer of the where the CPU is given, logical address is given, and it is passed through the page table and the physical. Where you if you are searching a 0001 00 is having a 01, and for a 01 it is having a 00. So 01 and 00 is nothing but a I, that is what is given, and this offset remains same. And depending on these two locations will be having a two different location in the physical memory.